will quantum computing affect blockchain? This video was created through the combined effort of the QRL contributors community. When you create a transaction, your private key, the key that only you know, will be used to create a signature that is attached to the transaction. The signature is mathematical proof that you own the private key that belongs to the public key. This way, the nodes know you are the rightful owner of the funds you want to spend and that the transaction is legitimate. After the node has verified the signature, it adds the transaction to the block. This method is safe because there is no way that any classical computer can find what private key belongs to what public key. Provided that you never share your private key with anyone, you can safely store your coins on your public key. This is a core value that blockchain uses. Sounds perfect. But hold on, what about a powerful quantum computer? That changes the game completely. It can exponentially decrease the time required to derive the private key from the public key, allowing attackers to use the found private key to forge transactions and steal your funds. Worse off, it will be a simple search of the chain to find public keys and steal the stored coins. Bitcoin started to store coins on the hash of the key, instead of a full public key at a certain height in the chain. This means that now only the hash of your public key is published. The hash of a public key cannot be used to find the private key, not even by a quantum computer. This sounds great, as it should make Bitcoin quantum resistant. However, this is incorrect. The fact that you store your coins only on the hash of your public key does not mean your public key will never be visible. When you make a transaction, you have to publish your public key so the nodes can verify the signature. The full key is openly included in your transaction. As soon as you send your transaction, an attacker could get your public key, for example, through a man-in-the-middle attack. This attack can even be used to prevent your transaction from reaching the nodes. This way, an attacker has lots of time to use your public key, find the private key, and forge a transaction of his own to steal your funds. Another place where your public key can be obtained is in the pool. Even when your transaction is already added to a block, the node needs 10 minutes to process your transaction. In this time, your transaction can be hijacked. For more information, see the link below to a paper where this type of hijack is thoroughly explained. The solution is to use a new type of signature scheme, a quantum-resistant signature scheme. This type of signature is mathematically different from current signature schemes in the sense that there is no classical or quantum algorithm that can break this cryptography. So even a quantum computer cannot derive the private key from the quantum-resistant public key. Can this simply be implemented in an existing blockchain and solve the problem? It is not that simple. There are several issues due to the decentralized nature of blockchain that will be explained in the next video. Even in the best possible result, it is impossible to protect the full 100% of the existing circulating supply. The safest solution is to build a new blockchain from scratch and implement a quantum-resistant signature scheme from the very beginning, Genesis block. QRL, the quantum-resistant ledger, has done just that, implemented a quantum-resistant cryptographic scheme from Genesis, making blockchain ready for the future.